Now, whether we talk about cloud versus the edge, or we talk about Linux versus Windows, or Intel versus ARM, it always comes down to applications. It's all about the applications. Ultimately, the growth of the edge is directly proportional to the growth of edge applications. And the next panel is going to explore that topic. I'd like to introduce the moderator, Jim Brisimitzis. I got that right? I actually had to ask ChatGPT how to pronounce it. Yeah, I did. He did it. Yeah. Jim approved it. Yeah. So, so Jim's a good friend and a mentor for me. He is the founder and general partner of the 5G Open Innovation Lab in Seattle. And if there's anything about the edge or 5G that you would want to know, especially from an enterprise or B2B point of view, Jim's really the guy. Jim would have that information. He has deep insight, energy, passion, and we were actually part of the first cohort at the 5G Innovation Lab. Jim, I'm sure I just did a partial introduction. If you could introduce yourself and the panel, I'll hand it off to you.
Thank you, Amar. Hello, everyone. My name is Jimmy B. As was mentioned, I'm the founder of the 5G Open Innovation Lab. For those that don't know, it's the software ecosystem that we're building for 5G. And as we'll get into today, there's this fundamentally large opportunity in the 5G world with Edge. We are backed by 18 corporate partners that include Microsoft, Intel, T-Mobile, Spirent, Nokia, Ericsson, and others. And we've had, including Aarna Networks, we've had now 101 teams come through our program. Those teams have raised collectively $1.641 billion. So when they said pigs can't fly in the world of telco, they can. We're going to dig in why the edge is going to play an important role with that. So I would like to invite our esteemed panelists up to kick off our session for today. First, we'll invite Shah from Meta. Thank you, Shah, for joining. Then we'll invite up Ronnie from NVidia. Thank you, Ronnie. Any seat? Yep. Feel free to. Ravi from Harman. Thank you, Ravi. And then Puneet from Ataya. Awesome. And before we get into our questions, maybe, Shah, we can lead with an introduction of yourself.
Yeah, sure. Yeah. Hi, everybody. Should I stand up? Okay. Hi, everybody. I'm Shah Rahman. Very pleased to be here. Thank you for inviting me, Amar and Jim. I'm here today to talk about a little bit on this, topic you can see, and any insights I can share. We've been warned to actually really focus on insights and not other things. Way of introduction, I'm from Meta, a group called the Connectivity, which has recently been disbanded. And we've done a lot of work with the industry across various different technologies. Prior to that, I'm a network and telco native for last over 2 decades, close to 25 years. Large companies like Cisco and Ericsson, and a couple of small startups. That's all.
Excellent. Thank you.
Yeah, hi everyone. My name's Ronnie Vasishta. I'm at NVidia. Been at NVidia now for about 2.5 years, and responsible for everything telecommunications and telco at NVidia. I was at Intel before NVIDIA for a couple of years. I was founder, CEO of a company that I sold to Intel in 2018. And at Intel, we really, I think, started that move to virtualized RAN and the RAN infrastructure. And the company that I had before that, we worked very closely with network equipment providers that were obviously providing proprietary-based equipment into the RAN infrastructure.
Excellent. Puneet?
Hi, everybody. Thanks. My name is Puneet Sethi. I'm with Ataya. We're focused on building connectivity, software-defined connectivity platform for private networks. And before Ataya, I was running the RAN business at Mavenir and actually building what Ronnie just mentioned, disaggregated virtualized RAN implementations. Not working?
Take the other one.
All right. Okay, maybe a quick repeat. So my name is Puneet Sethi. I'm with Ataya. We're focused on universal connectivity platform for private networks. Before that, I was with Mavenir, running the Open RAN business there. So basically building virtualized RAN implementation on COTS hardware. Intel, what Ronnie also mentioned in his introduction, we kind of was the leader in that space. Before that, I was running the infra business at Qualcomm for about 15 years. Before that, a few other jobs, all in radio access space.
Thank you, Puneet and Ravi.
Hello, everybody. I'm Ravi Puvvala. I'm the VP of Strategic Partnerships at Harman. Harman is a fully owned subsidiary of Samsung. We are all about bringing the edge and the applications into the automotive world. Hopefully, by the end of this panel discussion, I can portray a picture of how some of the $4 trillion market feeds into the automotive market.
Well, we're going to get to that. So we had a great explanation overview from Roy on what edge is, but I'm curious to get your perspectives on the edge. So let's start with that. Yourself, Shah?
My perspective on edge. I believe edge is, I would say, you can look at it from two perspectives. One is like an extension of cloud. So how do you really extend the cloud compute and ability to run workloads closer to the user, so to speak, right? And especially, and the question would be like, why do you really need to do that? Usually that's for a couple of different reasons. One could be that you have latency sensitive applications or something that have very hard latency constraints that you really can't go all the way to the cloud. You just don't have enough latency budget because there is an best effort internet between cloud and the user, right? Or you can also look at it from the other perspective, which is more from the user or the client perspective, where you may be constrained because of, from a compute or thermal or power, what have you. So in those kind of cases, you may want to offload some of your processing from your local nodes over to the edge, right? So that's sort of like the two ways that we think about edge. Like it's a kind of like a, I don't call it a marriage, but more like a midpoint or like an intermediate point between your server side or client, the cloud processing and the local / your device processing. That makes sense.
It does. Do you think from your standpoint, edge is here already?
Edge has been around for a while.
Yeah. One of the points.
It really depends on like how you look at it and how you characterize it. And I think John did a great job in terms of really pointing out the enterprise. Enterprise has been on-premise, all the things that you run on your campus is an edge, right? It's been around for a while.
Yeah.
So it really depends on how you define and LFH, their taxonomy and the definitions make a lot of sense. But when you start thinking about 7 or 8 different types of the ones that I did, in my team's analysis, it start to get really complicated. Like, what do you really call edge, right?
Right.
But the short answer is that I think it's been around for a while.
When you were explaining compute in a closet, we used to call that Microsoft branch computing. So the old is new again. Ronnie,
exactly.
How does NVIDIA consider the edge? So much of what you do in your platforms and capabilities is about, I would say, use cases on the edge. I'm curious to get your perspective on that.
Yeah, sure. So I think the edge is compute infrastructure connected, and we just heard great analysis of why it has to be more on-prem or closer to the end user. From an NVIDIA perspective, of course, we have based accelerated compute and the connectivity at the things, the foundation of everything that we do. And if you look at some of the applications that are becoming more ubiquitous, whether it be intelligent video analytics or factory automation and robotics, if you look at some of the data requirements to stay on-prem and data science that needs to happen on that data, and the acceleration of the data science, those applications are already starting to grow dramatically. And there's always, can't remember the number, but there's always a large amount of new data being generated every day that needs to go through either video analytics or some form of data science. So for our perspective, we have platforms that can accelerate that compute, can add AI into those workflows, and can make those latency feedbacks often much faster than they have been in the past. But what's very important is often that workload should be cloud native in the way it can run either at the edge or can be offloaded into the cloud or vice versa, or offloaded to the edge. And so the cloud native approach is also critical in all that we do.
One of the other critical components is connectivity as part of all of that. Puneet, this is a softball into you, my friend, but obviously connectivity is going to play a role in extracting that data, getting it to a point where it can be computed and so on and so forth. But I'm curious to get your perspective.
Yes, thanks for the softball. So I think that's a great question. That's what kind of think about this. That's a problem we're trying to address as well. And I kind of like the slide that Roy presented, and kind of helped clarify some of the things in my head too, right? If you just kind of divide the edge into three, I look at the slide in kind of three main categories: on-prem and telco edge, within from every edge that extends from after the on-prem all the way to the telco network, and then sort of part of the public cloud, right? The edge of the public cloud. So if you kind of start to think about that, the on-prem edge, we talk a lot about 5G as an enabler of that, but that is really because we're talking about latency sensitive applications, and we believe 5G is going to solve some of those problems, and there are good challenges that 5G will address. But a large part of these on-prem applications that exist today, as they become cloud native, they're going to need to talk to all different kind of devices that access those applications, not just via 5G, but via wired connectivity, via Wi-Fi, via weightless, via LoRa, NB-IoT, all these things. These on-prem applications, as they become cloud native, they will become, they will be part of this edge addressable market, and probably a larger addressable market than 5G edge application. So we have to think about those connectivity platforms as you're now wiring these devices to the application, whether it's a SCADA application in industrial shop floors, or these are enterprise applications hosted on Microsoft Cloud. You have to start thinking about how you software define the connectivity between the endpoints, PLCs in the industrial shop floors, or computers to the. You have to define that in a software way, because there are no wires that industrial companies can rely on. So that's a big piece of that. The telco edge, I wanted to just say one more thing on that. I think a large part, we keep talking about the telco edge. This is the compute infrastructure deployed at the site, or in the telco data center, or if telco is leveraging public cloud as part of that, right? So the primary use case for that really will be the telco workloads. Because one transformation that's happening with 5G in the telco space is that the telco workloads are becoming cloud native, starting from RAN, baseband implementation, CUD implementation, to packet core, to management system. Everything is a container. So that's the only use case I see there, because the consumer apps cannot really be hosted there, because all the the life of the packet is encrypted until it kind of gets out on the other side of packet core. So those are kind of my views that I thought a little bit on top.
Oh no, thank you and Ravi, I'm going to come to you in just a moment, but we had a really good early debate, us and Shah, about what is the killer use case. Shah, obviously you led with Metaverse. That's it. It's the Metaverse. Explain. I'd love to get your perspective on that.
Yeah, definitely. I think at the present time it's really difficult to kind of describe a killer app, because as you just hinted, that what's happening on the. So I think we have to separate the couple of things. One is the enterprise edge. Enterprise edge has its own use cases, which are very enterprise specific. It could be video conferencing, it could be your local filer, it could be a local RCS and whatnot, right? That's a different set of use cases. I think what we're talking about, the killer use case here, is more on the telco or the public cloud. So public cloud players started rolling out their edge ambition. If you think about Snow family from AWS, or if you think about the Outposts or local zones from the big threes, all of them now offer that, right? Or Anthos from GCP. I can just go on and on. So if you think about all of them, maybe your question is, what's the killer use case for those, right? Yeah. And the answer that I see is it doesn't exist, right? Yeah. It just doesn't exist today. So if you think about the telco edge and what you described are really self-serving. I think that's what we were discussing earlier. So what you're doing is that you're on a transformation. If you go back 10 years, almost every part of the network was very hardware centric. We were pulling in big fat hardware boxes, and the sizes kind of grew as the level of aggregation grew into the network, right? So you start with a very small box at home or on-prem. You go into the CO, it gets bigger. You get into the edge, it gets bigger. As by the time you go to the internet core, you're looking at multi-rack systems, right? So that's sort of like how a hierarchical network that's been built for the longest time. Now, in that scenario, today, over the last 10 years, gradually, we started moving towards a virtualized environment, right? I met with a couple of SD-WAN folks here. SD-WAN was one of the leads into that entire NFV movement. The workload just moving to virtualized environment or x86 kind of machines. And then you started seeing the control plane moving into the cloud, right? That was a few years ago. Now, what you describe, every workload is now containerized, right? Which is true, maybe not every, but most of them are. So you think about RAN, with Open RAN got disaggregated completely. DUCs can totally run in container, maybe not RU. Packet core alike. You think about any other network functions, they can all run containerized now, right? So this, but to me, those are very self-serving because what you're doing is that you're bringing efficiencies to your network. You're probably reducing your total cost of ownership, and you're reducing the cost. But you're not able to run a real workload or application that is outside of the telco domain. So someone like, things like remote surgery, things like autonomous vehicles, the world that I live in, I'm from a social media company, right? So the stuff that we run, all these use cases, I would say when you see some of those start running in Edge, maybe that's when we'll find the killer use case and you let into the metaverse. The reality is that we have some of the glimpses of metaverse experiences. It's certainly, there are very interesting things that can happen with the metaverse. The defining characteristic is the presence, the feeling of presence that everyone sitting in this room, we're feeling each other's presence. But that's not the case if somebody dials in from remote today, right? And the Zoom fatigue, and you see like this, all these big boxes. How do you get to a point where like people thousands of miles away, you still feel very close to them? We're not in that world yet. And it has a lot of, long ways to go to the road to metaverse. So I would say the killer app is not here yet.
What's interesting is many of the CSPs in their pursuit of monetization are looking for that silver bullet killer app. And I would argue it's apps at the end of the day and the services, but they haven't gotten there. One of the oldest industries that's been in edge computing now for decades has been the automotive industry. You're the expert in this, my friend. I'm not. But at one point I read that cars on average today, more modern cars, are generating north of 300 gigabytes of data a day, and yet the automakers aren't able to extract that data to make sense of it. I'd love to get your perspective on how Harman is trying to help. Well, rather, how is the OEM automotive industry trying to leverage what is promised with computing and apps and all this other fun stuff to better their experiences?
Yeah, sure. At Harman, we have a motto. It's called consumer experiences, automotive grade, right? So all it means is that we're trying to change how we can provide premium situational awareness and premium audio to the consumers. If you look at most automakers, right, they make a claim they're going to make $20 billion by 2030 from the consumers, right? And if you take the average of the top 20 car makers, that's, you got your $400 billion market that the industry is claiming. But we're not there yet because we're still laying the foundation of ensuring that every car has a 5G modem. And we have the ability to deliver that experience to the consumer, right? So it's the biggest claims that the car makers are making, and and it's the intermediate play of the multiple players, whether it is the mobile operators or the edge infrastructure players, sort of setting up the the framework in order to enable these experiences.
Interesting. So, controversial question for you all, since we're being authentic. Do the telcos play a role in this ecosystem beyond connectivity?
So let me kind of address that. Also, maybe by way of that same answer, point a counterpoint on that, the self-serving thing that you mentioned. I think so. Telco does play a role. I think in the way of driving this. I know, if you look at Roy's slide, what I call the Telco Edge, all the the columns between the on-prem and the public cloud edge is what I'm referring to as Telco Edge. The real, and the use case there really is not going to be consumer apps, because the packets, the user traffic continues to remain encrypted as it.
Can you hold the mic closer to you? There you go.
Continues to remain encrypted as it flows through the network. The actual applications for that edge would be as the telco network evolves. The RAN workloads, RIG, packet code, I mentioned that earlier. And the reason you think today, Shah, I think the reason I think you're saying it's self-serving, because you're viewing that telco owns that infrastructure and just lowering their own cost. But I think there's more disruption than that, just that. If you continue to go in this direction, you're assuming that the telco owns the underlying infrastructure. It doesn't have to be the case. If everything ran to packet core becomes virtualized, you could have service providers that only have software, that are software companies, where the actual compute infrastructure is owned by hyperscalers, and they deploy a network that is served by workloads deployed on that, and that completely changes the game as to who's the service provider and who owns the infrastructure. So I think there's more there that can happen. So I think back to your question, I think telco does play a role. They're driving this innovation in terms of how their workloads are moving edge native, cloud native, and orchestrated by the same sort of the container lifecycle management and so forth. So that's, I think, is a key role in kind of driving the ecosystem forward and creating some scale behind this activity.
Excellent. Ronnie, Shah and I were chatting about application constructs, right? And are applications for the edge, do they need to be quote-unquote edge aware, or are they just applications that look to the network for resources? How are you all thinking about where application building goes for the edge? Is it very much the same of what it is today, with just a whole new resource pool to tap into, or something more complicated than that?
Well, it's definitely more complicated, because the applications that we're talking about, some of them don't exist yet. If you look at maybe XR, which is augmented reality, virtual reality, mixed reality, headsets are just starting to come on the market now for consumer. There's some industrial applications that are starting to happen, and synchronization of those scenes to the real world, when those scenes being in digital twins often, that doesn't exist yet today. Some part of that application will stream from the cloud or be running in the cloud. The digital twin perhaps will be running in the cloud. The orchestration of the synchronization between the real world and the digital twin, and relaying that information to the headset, either a downlink and then the uplink back to the RAN network. That will have to be at the edge, and that orchestration, again, is just starting to be worked on today, and we have some pretty exciting demos at Mobile World Congress that are showing these kinds of things now. If you look at some of the intelligent video analytics, that does exist today. Intelligent video analytics, you mentioned earlier about in retail, for instance, there's some very exciting applications that have already been developed by a very large ecosystem of ISVs, and that infrastructure is primarily on-prem or close to the point of use, because you want to have real-time. Somebody walks out a store with something, you don't want to be able to look at it 5 minutes later. So those kind of things are very dependent upon the application. I could go on. There's many new applications that are yet to come out. So going back to the early question about, I'll just answer one about killer app. I don't think there's one killer app that is going to make the edge or a deployment of compute hardware and infrastructure connectivity all of a sudden make sense. I think it's just a rising tide of many of these applications.
And just a noodle on that for a moment, an open question for all of you. What's the killer segment? Who leans in first? Is it the enterprise? Is it consumers? Who leans in first? Ravi?
Yeah, as I said, the car makers already started to charge for the experiences. Recently BMW started to talk about how they're going to charge for the heated seats. the trend has already begun, right? It's all about setting the kind of the ground play about why you want to pay for your features, and the software-defined vehicle is is creating that environment. People are going to be used to pay for new experiences in your vehicle, and as Roy pointed out about the autonomous, we are moving towards automated vehicles, right? Even the U.S. government talks about automated than autonomous because it's more about showing the dependence with the infrastructure. And when you have the dependence with the infrastructure and you have these experiences to be delivered, right? In the utopian world, you're sitting in a self-driving vehicle and you have nothing to do but watch TV or play games, yeah? So that's kind of the real reality where the consumer will see the real need and why they want to make sure, you want to have the same experience as your home. So when does that happen and when does the consumer feel it? That's kind of where we are in the middle of the reality.
Ronnie?
Yeah, I would say absolutely enterprise moves first, and campus. And that, if you bring it back to deployment over a RAN, for instance, it's just much more controllable and deployable and quantifiable, the benefit in an enterprise environment. And we're seeing that with robotics and intelligent video analytics and even some XR experiences. Although I would say if you go to central London and you go to the Harry Potter experience, the David Attenborough Green Planet experience, or you go to Universal Studios and you have the Harry Potter experience, there you can walk around with augmented reality connected on 5G. But we still see that kind of more as an enterprise play than a consumer play.
Agreed. Shah?
Yeah, I'm just going to +1 on that because I think that the experience that you're describing sitting in that car, I think is still years away. That's kind of my view. Even if we think about Metaverse or all the XR experiences that Ronnie was talking about, we are starting to see that the enterprise is a lot more receptive of those. There are productivity use cases. There are real functional use cases, whether it's like an architectural drawings or it's design, creators, what have you. There's many use cases that enterprise are really clicking on, and they're actually saying that when do we get to use this, right? So which is a lot more pull than actually kind of like I'm sitting in the car, because we're with this generation, or even maybe the next, is still very used to be behind the the wheels and then basically drive that. So I think that's a little bit further away, but the enterprise is like right here, right now, and as they start going into more XR and more Metaverse type experiences, they are going to need the edge, and whether it's an on-prem edge or whether it's a rented edge from the telco cloud, the Telco Edge, or public edge from the cloud providers, whichever it's going to be. But I think the enterprise segment is going to move fast. Yeah.
Gartner would agree with you on that. They published a study, I think it was 2 months ago, that said 50% of enterprise data will be created outside of enterprise data centers, right? We have a startup. We have several startups in our batch, but one of them, actually, when they do surveying of farmlands, they use LiDAR and other photosensing equipment. They're generating on a 5 acre block over 10 terabytes of data in a place that there is no connectivity, right? And so moving all that data and making sense of it in the public cloud doesn't make sense to them. And so they're kind of begging for edge computing and better connectivity to be able to process all that data and then just move the process data to where it needs to be. And that's where we think the edge is quite real. Puneet, last final words?
So I think I kind of agree with what Ronnie and Shah mentioned. I think the enterprise stuff is already happening. The other thing that I mentioned earlier, telco, is another area where this is also moving pretty fast. Big operators here in U.S., Verizon, they have thrown their weight behind this. All their new deployments are moving to be more virtualized, and sort of that's driving a lot of activity in this space as well. And then in enterprises, as I mentioned earlier, especially with industrial customers, they have applications today that run on computers natively. They are making, these SCADA application, HMI applications, historian, all this stuff in factories and shop floors. They're making those cloud native, and all those applications don't actually need 5G. They already are served well with the connectivity options that exist today. So I think you're going to see that momentum continues to happen while, we at the same time, we're going to figure out how we deliver improved latency over 5G and enable some of these AR applications that the previous speakers talked about.
Agreed. Well, last open question, and we'll just take a quick answer from each of you before we wrap up here. There's a lot of effort going into the Edge ecosystem, right? LF Edge has Kamara as a project. GSMA has their own edge computing project. How do we coalesce this? How is it all, in your opinion, guys, coming together? Is there a role for the hyperscaler clearly working with the telcos, obviously driven by the enterprises? I'd love to get your perspectives. We had a great conversation on apps. I'd love to understand from your industry perspectives, where does the infrastructure actually play out? Shah, would you like to lead?
Yeah, sure. I think probably one thing we haven't touched on, there's a lot of talk about connectivity and telco from an edge perspective, as well as the data explosion. I think what you just described is going to make it very, very, very difficult to pull all that data. You're going to kill the network no matter how big the pipe is, and then think about the processing side of things, right? And we're also moving into a world where there is the whole privacy and security is coming into the picture, right? So one of the things we think about edge, and that's something making our life hard, is the notion of the trusted compute environment, right? So you need trusted execution environment, you need secure enclaves, you need not just the data security. If you start, he hinted something very important just a minute ago about the you can't start executing things in the middle of the network because you have an end-to-end secure network. So you got to cut that open. If you cut that open, you have to extend that trusted zone, right? And you have to have that secure enclave, which is going to be a big problem. I just don't see enough of that in the industry. So if you ask me, I see that as a big gap. And right now, it's being talked in, kind of the world of differential privacy and federated learning in a whole different plane, which is like the hyperscaler and the cloud providers. There needs to be more work in that kind of area, because that, as soon as you find that kind of this wave of the killer apps, the next thing you're going to hit is that now we got to solve that problem. So we need to start thinking about that from an infra perspective. How does it become much easier to run, pretty much anybody's applications on anybody's infrastructure, right? Yep. That's the utopian world that we're looking at, and we're years away from that.
Totally agree. Ronnie?
Yeah, so I think what's making things a little bit complicated, a little bit busy, is the fact that the infrastructure, compute infrastructure, network infrastructure is coming now from multiple different vectors. So, of course, compute infrastructure on-prem could be a standard server, could be a NIC. Connectivity infrastructure could be Wi-Fi, could be Ethernet, could be RAN, could be 4G, could be 5G. Orchestration could be multiple different orchestration capabilities. And so I think that in itself, because everybody has a part to play or wants to play a part, is making things a little bit more complicated. I think in the cloud, things have settled down a lot more because there's major players that have, but not all clouds are created the same, right, in terms of the infrastructure that is within the large cloud service providers. So I think it's going to be a bit of a Wild West for a while. I don't think this is really going, because everybody wants to have a play in I think the ownership of that infrastructure.
Agreed. Ravi, final words, my friend. No pressure, we have to wrap up.
Right. Today, the automotive industry is driving these conversations in a consortium called 5G Automotive Association. Yeah. So there we define the near-term mobility applications and the long-term safety applications. Yeah. So we have a joint collaboration between the auto OEMs and the telcos through a working group called MEC for Auto. This is where we are kind of defining how this collaborative infrastructure is going to be deployed.
Yep, there's going to be a lot of that. Well, friends, it's been awesome. It feels like we had a beer here and we're just catching up, so thank you very much. We could probably go on for hours more, but we'll wrap up here. Amar, thank you for hosting us, and thanks for all the guests for spending some time with us and sharing your wisdom. We appreciate it. All right.
Thank you.